Dr. Raghu Raman Sekhar. So his topic is importance of intelligent battery management in the electron economy. Dr. Raghu Raman is a PhD scholar and vivid researcher. He did a lot of research, and his vision is to ensure that world has access to safe batteries. If not the green batteries, at least safe batteries.
Good afternoon, everyone. Thank you for this opportunity. I hope you all had a great lunch. So batteries, according to me, are like babies. You need to take care of these batteries while they're idle, like when the baby is, like, let's say, like sleeping, or when you're feeding the baby, or charging it, or even when the baby is running around or discharging, whether it is mobility or any other space. Uh, so my topic today is how are we going to look after these batteries, which are very very similar to babies, in an intelligent way, and why we need to do it. So the market drivers for battery management systems, we all know we are assembled for the same. There is a huge proliferation in the adoption of electric vehicles. There is a global transition towards renewables, wind power, solar power, etc. There is governmental push across different continents. Governments are very very keen to adopt battery powered vehicles, and we are seeing like a trend in reduction in the lithium ion prices, although the last year shows a different trajectory. And obviously there is consumer demand for some of these gadgets like your mobile phones, tablets, and so on. But all put together, if you look at the market share, right, mobility for batteries is close to 75%, three-fourth. And all the electric vehicle batteries require a battery management system. It is very, very clear, okay? Especially the ones powered by lithium ion or lithium based batteries, then that is going to be the trend moving ahead. We are going to see fewer or probably close to zero lead acid based electric vehicles. Now, what is a BMS or a battery management system? It finds applications in multiple areas, but let's focus on electric vehicles and let's focus on energy storage systems. In electric vehicles, it sits within the battery pack and then kind of is the brain of the modern battery pack. It talks to the charger, it talks to the motor drive, and ensure the battery is always safe. And in a renewable energy system, it still sits within the battery pack, but in this case, it talks to an inverter or a DC converter to ensure there is a stability in the grid. What does a BMS do? A BMS monitors battery health first. Second, it ensures there are no fire accidents ideally, or there are some other accidents too. So for example, your range prediction can be wrong, your health prediction can be wrong, and this can have several cascading effects. And obviously some of the modern ones continuously share data, and there is a lot of optimization from the control point of view, control strategy. If you look at the emerging markets today, there are two key problems in the BMS space. One is your cells and BMSs are imported from one country and you're assembled here, let's say in India. And because of this, there is at least 30% reduction in battery life. Second is there's many fire accidents. And obviously, there's a lot of system failure and, let's say, shorter driving range in case of electric vehicles. Next problem is that if you are a battery pack manufacturer, you don't just cater to one particular segment. You have two-wheelers, three-wheelers, bicycle, drones, energy storage, and so on. And therefore, you'll probably have different BMS makers to kind of work with. Therefore, your supply chain is kind of screwed up. Next, let's see what is the difference between a PCM, which is a protection circuit module, and a BMS, which is a battery management system. Obviously, both of these have applications, but mobility and energy storage spaces prefer a battery management system for obvious reasons. A PCM is just a analog circuit which is capable of detecting over current, over temperature, and over voltage, and kind of protecting the batteries at times. But then it cannot do something like a communication. It cannot get newer programs into the battery management system for optimization, and it still cannot connect to the software. Next is if you have multiple batteries in parallel, it cannot communicate with each other. And obviously, therefore, the battery management system is probably 50% more expensive than your PCM. PCMs find applications in like a, let's say like a mobile battery bank, which all of us carry around, and some, let's say, but not critical applications. Maybe it could be a home UPS and so on. BMSs, on the other hand, find applications at the higher end, like an electric vehicle, intelligent, UPS, and so on. Different types of architectures are there in the BMS. You have like a centralized BMS where a single PCB kind of monitors the entire stack of the battery and makes decisions accordingly. Second, we have what is called as a BMS master-slave approach, which RC Lab successfully does. Master-slave approach is where you have multiple PCBs talking to each other and ensuring there is constant communication between them. There is constant studying of battery health and kind of sharing it to any other server within the company or to a customer. Next is there are requirements where you have cell level BMS. Not so popular yet, but there are some requirements. Next, why do we need an intelligent BMS, right? Why? What is the need? First, definitely you can improve battery life and you can optimize range in case of electric vehicles. Second is this smart BMS or intelligent BMS, right, can communicate whether it is with the motor drive or whether it is a vehicle control unit or an inverter. It can communicate critical parameters and recommend operating conditions for each of these applications. Next is safety. We all know how dangerous electric vehicle batteries can be. A poorly designed battery pack is a bomb. So we need to be very, very careful when we design the hardware, firmware, and the software that goes into it. Next is with increased data communication and understanding of these chemistries, we can have better prognosis of battery health and kind of predict when something is going, when a battery module or a battery pack is going to fail. Next, reliability. With increased understanding of these chemistries throughout the life cycle, when you understand cell level, it is easier to predict what is going on in the battery level. And therefore, with intelligent BMSs, you can kind of improve your state of health and state of charge predictions. Next is, what is a roadmap for an intelligent BMS? Yes, whatever I'm talking about, people are doing it, right? But what is the additional point? First, we deploy a BMS in an application. It could be an electric vehicle. Let's take the popular case, for example. Next, it works for about 5 years, 7 years, and after that, we call it end of first life. Okay, throughout this period, the intelligent BMS collects and analyzes data, and then at the end of first life, it is going to predict what is the capacity left in each of the module. Let's take an electric bus. You probably have 25 modules. In each of these modules, you will predict what is the capacity left and kind of identify the right second life application to which it has to go to. So what's happening now is your bus battery has to come back to a testing facility. You need to test the batteries, evaluate, characterize it, and then kind of figure out. With intelligent algorithms, this can be done real time, even before the vehicle kind of goes into your just before second life application. And then let's say you put it for an energy storage application use. Now the same BMS will still continue to work there if it's like a module level. And there is, with over the air updates, all we need to do is kind of configure new parameters to the BMS for that particular application, and it is good to go for the next, let's say, 10 years. So throughout the life journey of a cell, until it goes into recycling, an intelligent BMS will take care of the cell to battery to first life, second life, and recycling. So that's the concept of an intelligent BMS. Now, another concept is you constantly collect data and try to optimize for the current operating conditions. Batteries don't operate similarly in different weather conditions. I think one of the earlier speakers pointed that out. And therefore, we need specific algorithms to work in different climate conditions for a given application. So even that can be fine-tuned. What is the impact of having this, right? Obviously, we can improve safety by multifold. Next comes the reliability. If your scooter says you can go for 50 kilometers, you can blindly go. So the vision for RC Labs is just like Google Maps. If Google Maps says, okay, it's going to take 30 minutes for you to go to point B from point A, you kind of know 99% of the time it's true. So that is the level of accuracy we are trying to work for. Next is the hardware scalability. So we have few platforms where we can RC Labs BMSs can work from a bicycle all the way up to a 240 volt system. So the bicycle works around 36 volt. With the same architecture, we kind of scale using a master slave approach to a 240 volt system. Next is, obviously, the overall major impact is going to be greenhouse, reduction in greenhouse. I totally agree with Mr. Jude that yes, electric vehicles are not totally green, but ICEs operate around 25% efficiency, whereas electric motors up to like 80% or probably even higher. So it is still better than ICEs, but it is not the ideal solution for today. We have to move in the direction which Mr. Martin actually just pointed out. Next is increased life of the battery. We all know we are importing. I don't want the country to go from importing petrol to go into importing lithium, right? So we have to find a way. So with recycling technologies coming up, I think we can definitely reduce our import bill and increase the life of the battery. So what is a closed loop thing? Here we have an intelligent hardware with a chemistry agnostic firmware. The BMS hardware constantly collects data. There's data analysis giving out results to both battery and cell players. And then there's feedback to improve the hardware and the algorithms. So this continuously happens until we hit a plateau. And from coming from a research background, I know it is very hard to hit a plateau where you know, okay, this is the best we can do. So there's continuous research, continuous development, and this is what the future roadmap for intelligent BMS and RC labs is. Thank you very much.
Thank you, Raghu Raman. In fact, you made it very short and cute and apt speech.
Thank you.
I think we need more researchers like you to have safety batteries in future. One thing I like it is you said more on recycling. Probably I think that is another thing actually people should look at it. So recycling is the one actually we how to utilize the already used things. So may I request Mr. Jailendra is one of our panel member, and he is also president of Advanced Computing Communication Society of India, to give a memento to Dr. Raghu Raman.
Hello. Thank you very much.
You can talk to Jailendra for the society what he is going to lead. It is Advanced Computing Communication Society.
Thank you, sir.
You all heard of IEEE. This is the one actually which we are, I mean, even I am also part of that.
Thank you, sir.
What we are planning is it's going to be IEEE of India. So you can just connect, and one more secretary also is there here, Mr. Mahesh. You can just stand up, sir. So he is also going to be another panel member. Anyhow, thank you. Thank you, Raghu Raman.